it's time to choose between the red pill or the blue pill. Just kidding, drugs are bad. Okay, let's do some math. And starting off here with solving rationals, the bottom line is you want to get rid of the denominators. And to do that, you're going to multiply everything by the least common denominator. And then once the denominators are gone, you can solve the equation like normal. In other words, you will multiply the tops of all of the fractions, all of everything, times the exact same thing, whatever the least common denominator is. And in doing so, that'll cancel whatever the denominators are, and then what doesn't cancel will actually multiply out. And then whatever remains, you distribute, combine like terms, you solve like normal. Sometimes in doing this, an extraneous solution will occur. If that happens, just check for it. The way you would check is this a number that you got? Is this solution that you got something that would make one of your denominators 0? If so, can't use it. So looking at this little quick example, what should we multiply by? Well, the least common denominator, which between x and 3 is 3x. So what I want to do is I want to multiply everything times 3x, including the 21. And I'm not multiplying top and bottom, I'm just multiplying straight across all sides on the tops. So if I multiply 3x times 4x plus 1 over x, and I multiply 3x times 8 over 3, and equals 3x times 21. Then in doing so, the x's here would cancel, the 3's here would cancel, and at the end here nothing would cancel. And now I'm just going to distribute, combine like terms, and solve like normal. So 3 times 4x is 12x, 3 times 1 is 3, x times 8 is 8x, and 3x times 21 is 63x, and then we combine some stuff, and you would solve it like normal. I'm not really interested what that equals, but you just add stuff together, subtract, divide, your normal algebra 1 steps. But that's the basic idea there. Is I had to multiply everything times the least common denominator, which was 3x, and in doing so, you notice that the denominators all canceled. There are no more denominators. That led me to what I have over here in blue. And then once you're at that point, you're solving like normal. That's the key thing. Okay, so let's see an actual example worked out in full. So here, my denominators are 2 and 5. The least common denominator from that is 10. Okay, that's so if I multiply everything by 10, which is 2 times 5, then that'll get rid of all of my denominators. I won't have denominators anywhere. So I'm going to take x over 2. I'm going to write it as 2 times 5 that I'm multiplying by, and you'll see why, because it'll be easier to cross stuff out afterwards. So multiply times 2 times 5 times this top part here, and the right hand side as well. Multiply that times 2 times 5. Okay. Well, the reason why we're doing it like that is because, and writing it in factored form, whatever you multiply by, write it in factored form. It's because you should be able to easily cross out some factors. Here I can cross out the 2's, leaving me with just 5 times x is 5x. On the second fraction, I could cross out the 5's, leaving me to distribute the 2 to both of these. 2 times x is 2x. 2 times 2 is 4. And then 10 times 3 is 30. Now I can just solve this like normal. So added together is 7x plus 4 equals 30. Subtract the 4. 7x equals 26. And then just divide by 7, and it looks like my answer is a fraction, but big whoop. So my answer is 26 over 7. Now clearly, since I don't have any x's in my denominator, I don't have to worry about extraneous solutions there. Alright, so a little bit harder this time with more x's, but let's identify what the least common denominator will end up being. I have an x plus 4, and again an x. So it looks like the two main factors that are in my denominator are the x and the x plus 4. So I'm going to multiply everything times, I'm going to write this down, my LCD is x times x plus 4. Okay, that's because it's just this denominator times this denominator. That's the least common denominator that I can get. It's not always the product of the denominators, but in this case it was. So if I multiply each and every single one of these things on the tops only by this amount, then all of the denominators will cancel. I'll still have some things to distribute and work with, but at least the denominators will cancel. So let's multiply that out. Okay, x times x plus 4 times the x plus 3, and this is over x, minus x times x plus 4 times x minus, or sorry, x plus 1 over the x plus 4 equals x times x plus 4 times 4 over x. Now, remember, because we multiplied every single top times the LCD, that allows me to cancel out denominators everywhere, because here I have an x and here I have an x. Here I have an x plus 4 and an x plus 4. And again, here I have an x and here I have an x. Once the denominators are gone, this problem's a lot easier to deal with. Okay, I'm going to FOIL these two together, which basically just means I'm going to have an x squared. The 4 and the 3 would add together to make the middle amount of 7x, and they would multiply together to make a 12. Just a little shortcut on foiling. This amount here, when you distribute the x to this, it's going to be x squared plus x. However, we have a minus sign here, and that minus sign is going to have to distribute to 1. So I'm going to write the minus sign. I'm going to put parentheses around this still, because I need to remember that I'm still going to have to distribute this to both of them here next step. So you got to be careful on minus signs like that. That does make that harder. And then here, the 4 just needs to distribute to the binomial, so that would be 4x and 16. Okay. Now, in distributing the negative sign there, okay, that's a minus x squared, and this is going to change to a minus x as well. I'm just going to write that there. Oh, look, I've got an x squared and a minus x squared. Yay, those will cancel. 7x minus x is 6x. And then the 12 is the only remaining thing on that side. Then I've got the 4x plus 16. Okay, so I'm going to subtract the 4x to the other side. We're just using regular solving techniques now. We're also going to subtract the 12 to the other side. So the 4x cancels, the 12 cancels. 6x minus 4x is 2x. 16 minus 12 is 4. Divide both sides by 2, and you get that x equals 2. There you go. And just a real quick check shows that this is not extraneous, because if I plug in 2 to these denominators, that doesn't create a 0 anywhere. So we're good. Okay, this time there's a little warning letting us know that there will be an extraneous solution this time. So we'll pay attention for that. Since there's nothing that my denominators have in common, then really the LCD is just the product of these unique things, the 2 times the x minus 7. And you can bank on that. That if your denominators have nothing in common, no common factors whatsoever, then the least common denominator is just the product of whatever unique factors you have. So 2 times x minus 7 is my LCD. If I multiply all three of these fractions on top times 2 times x minus 7, then the denominators cancel. I solve like normal. So 2 times x minus 7 times the first fraction, 2x minus 9 over x minus 7, plus 2 times x minus 7 times x over 2 equals 2 times x minus 7 times the 5 over x minus 7. Now then we can cancel some things. In the first fraction, the x minus 7s will cancel. In the second fraction, the 2's will cancel. And then again, the x minus 7s will cancel. No more denominators is a good thing. Now we can solve this like easy. I'm going to distribute this 2 to both of these two. 2 times 2x is 4x. 2 times minus 9 is minus 18. I distribute this x to both of these two. X times x is x squared. X times minus 7 is minus 7x. And then multiply the 2 times the 5, it equals 10. So we'll combine like terms and do all of our solving techniques here. Looks like the x squared doesn't have anything to combine with. A positive 4x and a minus 7x make a minus 3x. I've got the minus 18 here. Okay. We're going to subtract the 10 from that though, because you have to get everything to one side. The reason why we have to get it to one side, this problem is quadratic. So everything to one side, and then we'll use factoring. And so negative 18 combined with negative 10 makes negative 28. X squared minus 3x minus 28 will equal 0. Now then, this is a trinomial, 3 terms. We're going to factor it using the M&A method. Multiplies to 28 would be 4 and 7. To make 4 and 7 add to negative 3, then the 7 has to be negative, and the 4 has to be positive. So that's x minus 7 and x plus 4. Once again, we double check to make sure that negative 7 times 4 is negative 28, so it multiplies correctly. Negative 7 plus 4 is negative 3, so it adds correctly. Those are my two numbers, which give me those two factors, from which the solutions are x equals 7 and x equals negative 4. Just switch the signs on those. So those are the answers. However, remember we said that there were some extraneous solutions, or at least one of them. So now I just look at the 7 and the negative 4, and I go back and at the original problem. Could either of these be plugged in somewhere to cause a problem? Yeah, the 7. Okay. Back up here, x minus 7 is a denominator. If you plug 7 into that, 7 minus 7 is 0. You're dividing by 0. That's a problem. So yeah, that means that the 7 is extraneous, and only the negative 4 is a solution. So especially when you have a quadratic equation like this one, you do have to be aware that there could be an extraneous solution. Quadratics aren't the only ones that give you extraneous solutions, but it's definitely more often. Okay, see you tomorrow.